Hello makers, welcome to another episode of CADurday, where we take a look at some cool and useful computer design tools and maybe share a cat photo or two in the process. So not too long ago I made some custom engraved glasses for a friend of mine using the laser engraver here at Exploration Commons. Of course, if you end up making one awesome thing, it stands to reason that you'll be asked to make another. So what else can you put the logo on? I was asked. But before I could venture an idea, one was chosen for me. How about 3D printing? Explained my friend, as he proceeded to rattle off about a dozen more ideas for custom printed objects in what seemed to be a matter of seconds. Ah, great. What have I got myself into? Worry not, because today we're going to be modifying an existing 3D object to include a custom logo using Autodesk's Fusion 360. Now, I know what you might be thinking. This sounds super easy, right? Anyone can do that, right? But what if that object is an STL file? Now, for those unfamiliar, STL file format is by far the most common format you're going to encounter when sharing objects for 3D print. 3D file sharing sites like Thingiverse, Thangs, Yegi, even Prusa printers all host files in the STL format. Of course, there are other formats such as 3MF, SolidPart, and STEP, but that's for another video. The Achilles heel of STL files is that they are notoriously difficult to edit. Until now. First off, we need to talk about the many wonderful resources that are out there that cover the process of converting a mesh into an editable, solid body, which we are accustomed to working with in Fusion 360. Head on over to YouTube and use Fusion 360 STL as the search term. Be mindful of content produced more than a year or two ago, as the workflow and features may not mesh with the current version of Fusion. I've watched several and would recommend anything produced in 2021 or 2022. Several of the videos go into greater detail about how to use the mesh features of Fusion to reconstruct all facets of the geometry, and by and large are excellent tutorials on the subject. I'll be taking a path of least resistance approach to solving the problem of putting my friend's logo on a 3D printable bottle opener. Let's get started. The process I'm going to follow is based on the hobbyist license, so I'll be skipping the workflow that covers the prismatic method of mesh conversion. Definitely check out the tutorials on YouTube if you're interested in a more rigorous reconstruction. When I use mesh to solid body conversion for other projects, it's typically not to make large structural changes to an object. For that, I would just remodel the part, but rather to fix small little issues that pertain to the specific project I'm working on. That is to say, I've downloaded a pre-made STL file, and in the process of building the project, I need to make small changes. For example, mounting holes for fastening parts together might be in the wrong location, or an incorrect diameter, or maybe there just needs to be a little bit more plastic in a certain spot to add strength. The hobbyist license workflow has only 3 steps. First, insert the mesh. Second, detect face groups. And third, convert mesh. Once you have a solid body, we're back to a regular CAD workflow of identifying a surface to sketch on. In this case, selecting and deleting the central triangle on the face of the bottle opener creates the perfect surface to add a logo. So let's get a new sketch going on the prepared surface and insert the logo from an SVG file. We'll resize the artwork to fit and get it roughly centered. Although maybe I thought about turning this 90 degrees, but I think maybe that would cause some of the features to be too small to print legibly. One thing to keep in mind when working in CAD is to keep perspective on scale. This is a small bottle opener in reality, but on my screen it's about 1 foot across. While 3D printers are good, there comes a certain point where you begin to lose detail as things get really small, so keep that in mind. There we go. Now that it's placed, let's fire up the extrude command and we're just about finished. I really can't say enough nice things about being able to design artwork in another application like Adobe Illustrator or Inkscape, and then bring it into Fusion and place it on an existing design. It's the perfect mix between art and engineering. Of course, the last step before 3D printing is to convert our solid model back to an STL file and send it to Prusa Slicer. I think we'll try a 0.15 layer height with the default settings for generic PLA. Quick scan up and down the slice looks good, so let's go ahead and send this to the printer. Overall, I think Autodesk has done a great job of bringing this feature to fruition, and the community of makers in providing a lot of great details on how to use this feature. Here at Exploration Commons, we have access to the educational license of Fusion 360, so you're welcome to come in at any time we're open and try the software for yourself. As always, I hope this quick look into the workflow of using Fusion 360 to edit STL files gives you insight and possibly inspiration for your next project. Thank you for watching, and I hope to see you again soon. Take care.